Hello, College Algebra, and today we're going to do 2.6, which is all about combinations of functions, or composite functions, but within that we add, subtract, multiply, divide functions, and all sorts of other things. So, function operations. If I have f plus g of x, that's the same thing as f of x plus g of x. Typically, we assign it as a different letter, so for the sake of argument, h of x is nice. Important thing to note is the domain is the set of both original domains and the new one, or an intersection of all of them. So for example, if f of x's domain was 0 to infinity, but both of these were all real numbers, the only values that count would work for all three. So in this case, the domain would be 0 to infinity. So this first one, we're going to say f of x is x squared. G of x is the square root of x plus 1. We all agree the domain for this would be all real numbers. I have no restrictions. But here the domain, x plus 1, has to be greater than or equal to 0 because I can't have a negative underneath my square root. So I know x has to be greater than or equal to negative 1 by subtracting 1 to both sides. So my domain would be negative 1 to infinity. Now, if I were to add these two functions together, we get f of x, which is x squared, plus g of x, which is the square root of x plus 1. And then I would look for any like terms or things to combine. Unfortunately, I don't have anything, so that would be my function with a domain of negative 1 to infinity. Because I get no restrictions in my f function, the g function has them, and the h function here, this f plus g, has the same one. I can't have a square root of a negative. Now, whenever you see this, it just means that x equals 3, just like if f of 3 was happening. So we're going to plug 3 in for f plus g of x function. So I'm going to plug 3 in right there. So we get 3 squared plus the square root of 3 plus 1. 3 squared is 9. Oop. 3 plus 1 is 4 underneath the square root. The square root of 4 is 2. So 9 plus 2 tells me that f plus g of 3 would be 11. F divided by g, so I get my f function up top, which is x squared, over my g function on the bottom, which is the square root of x plus 1. Now this one actually also creates another restriction. Remember, dividing, this bottom part cannot be 0. So now I know the square root of x plus 1 cannot equal 0. Well, square both sides, I would get x plus 1 cannot equal 0. Minus 1, I now know that x cannot equal negative 1. So my domain is now parentheses negative 1 to infinity, where earlier it was a bracket because negative 1 could be included. Now it cannot. And now f over g of 3, I'm just going to plug in 3 for both spots. 3 squared over 3 plus 1 square root. So I'm going to get 9 up top over square root of 4, so that's going to be 2. So I get 9 halves. Remember when we multiply multi-termed expressions, if I have a 2 by 2, we can think about it as foiling. First, outside, inside, last. So we would get, 3x squared minus 21x plus 4x minus 28. Combine like terms, 3x squared minus 17x minus 28. But if I do foiling from this one, I would get first, outside, inside, last. I missed this 4x term. So be very careful in your multiplyings. We've talked about this before, but just be careful with the distribution. This is a 2 by 2 system. 2 terms, 2 terms. So I get 4 things being multiplied together. This is a 3 by 2 system, 3 terms, 2 terms. So I get 6 things being multiplied together. So x squared times x would be x cubed. X squared times 2 is 2x squared. 4x times x is 4x squared. 4x times 2 is 8x. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. We can, of course, then combine like terms. So we get x cubed plus 6x squared plus 7x minus 2. Lastly, we have compositions. Compositions is putting a function into another function. So first, let's think about f of 2. That just means I'm putting 2 in for x. So I'm going to get 3 times 2 minus 5, which would give me 1, because 6 minus 5 is 1. Here, we have g of 0, so I'm putting in x equals 0. So I'm going to get 0 squared minus 1, or negative 1. Now, when I see f of g, that's what this circle means, it's an O for of, or something like this, what's really happening is I'm taking the entire g function, because it's on the inside, and I'm plugging it in for the x in the f of x function. So I'm going to get 3 and minus 5. But instead of having this x, we get x squared minus 1. And then I'm taking it one step further. I know that x equals 3. So that x is being replaced with a 3. So I get 3 squared, which is 9, minus 1 is 8. So I get 3 times 8 minus 5. So 3 times 8 is 24, minus 5 gives us 19. Here we get f of g of x, so I'm just doing that g function in for the f function. So the f was 3x minus 5. So I get x squared minus 1 minus 5. I suppose we could also distribute this 3. So 3x squared minus 3 minus 5. Combine like terms, 3x squared minus 8. Now on this one, you see that the f is on the inside. So the f function, which was 3x minus 5, whereas the g function was x squared minus 1. Now, the entire f function is replacing where the x is in the g function. So I get g of f of x equals 3x minus 5 squared minus 1, which means I can square this out. 3x minus 5 times 3x minus 5, 9x squared minus 15x minus 15x plus 25, combine like terms, 9x squared minus 30x plus 25, and I still have this minus 1. So therefore 9x squared minus 30x plus 24. Decomposition of functions. So what we just talked about here was composition of functions, taking something and putting it in for the other one. Decomposition is you're given the answer or the end and you're going backwards. So looking at this, I would see that I have this x plus 1 twice. So I would say that my g of x is x plus 1 and my f of x would be x squared minus 3x plus 4. Because if I write it that way, it looks like I'm doing f of g of x, where I'm just taking this x plus 1 and I'm plugging it in for those x's. That also means that, naturally speaking, there's multiple compositions for functions if you're looking for one. This isn't the only possible answer. There's multiple answers you could have gotten here. So that's exactly what we're doing. You're trying to find a g of x that would go in, so we just did that, x plus 1, and an f of x function would be on the outside, so x squared minus 3x plus 4. Here, h of x, well, it looks like this x minus 5 is what's plugged in, which means if this whole thing was just an x there, f of x would be the square root of x plus 7. Alternatively, you could argue that g of x is the square root of x plus 5, and f of x was just x plus 7. Either one of those would work, because if I took this whole chunk and put it right there, I would get this answer right here. Or if I took this piece and plugged in for this x, I'd get the same answer. So either way, that would work for this problem. Thank you for listening, and I hope you have a great day.